Hearing and equilibrium in air. Hearing and equilibrium in air in vertebrates. Hearing is important to vertebrates. It alerts them to either nearby, far away, dangerous activity. It is also important in the search for food, mates, communication. Hearing and equilibrium are considered together because both sensations are received in the same vertebrates organ. The air functional units of vertebrate air. The vertebrate air has two function units. The auditory apparatus, vestibular apparatus. Auditory apparatus. The auditory apparatus is concerned with hearing. Vestibular apparatus. The vestibular apparatus is concerned with posture, position, and equilibrium. Some results when pressure waves transmit energy through some medium, air or water. Hearing in air poses very serious problem for vertebrates. Middle air senses sound pressure sensor, but in sound pressure is less than 0.1% of the pressure in water. Adaptation to hearing in air. Adaptation to hearing in air resulted from the evolution of an acoustic transformer that incorporates a thin stretched membrane called either an eardrum, tympanic membrane, or tymphanium that is exposed to the air. Air in amphibians. Amphibians, Anorans frog. The air of Anorans frog consists of flowing parts. A tympanium, a middle air, and inner air. The tympanium is modified, integumented. It vibrates in response to sounds. It transmits these movement to the middle air. It is the chamber behind the tympanium. पोस्टीरियर व्यू ऑफ एयर ऑफ ए फ्रॉग. ये स्ट्रक्चर दिखाई गई है फ्रॉग के एयर की. मिडल एयर. द टचिंग द टेम्फेनियम इज एन ओसिलस, अ स्मॉल बोन स्ट्रक्चर कॉल्ड द columella steps. The opposite end of the columella touch the membrane of the oval windows. This membrane is present between the middle air and inner air. High frequency 1000 to 5000 Hz sounds strike the tympanium. These are transmitted through the middle air via the columella. It causes pressure waves in the fluid of the semiauricular canals. Working mechanism. The pressure waves in the inner air fluid stimulate receptor cells. A second small oscillus, the operculum, also touches the oval window substrate. Bone vibration transmitted through the front appendage. It pectoral girdle causes the oscillus to vibrate. The resulting pressure waves in the inner air stimulate a second patch of sensory receptor cells. It is sensitive to low frequency 100 to 1000 Hz sounds. Muscles attached to the operculum and columella look either or both of these oscillus. It helps the frog to screen out either high or low frequency sounds. Significance of high and low frequency mechanism. This mechanism is adapted because frog use low and high frequency sounds in different situations. Mating cells are high frequency sounds. These are important for only part of the year. Breeding season. Low frequency sounds are warn of approaching predators. Salamanders lack a tympanium and middle air. They live in streams, ponds, caves, beneath leaf litter. No mating cells. They have no mating cells. They only sound they hear are transmitted through the substratum and skull to the inner air. The senses of equilibrium and balance in amphibians involve the semiauricular canals. These semiauricular canals help to detect national movement and gravity. एयर इन रेप्टाइल्स. द स्ट्रक्चर ऑफ एयर इन रेप्टाइल. पहले हमने फ्रॉग की एयर के बारे में पढ़ा है, अब हम एयर इन रेप्टाइल्स के पढ़ रहे हैं. द स्ट्रक्चर ऑफ रेप्टालियन एयर ऑफ स्नैक्स. द एयर ऑफ स्नैक्स लैक अ मिडल एयर कैविटी एंड अ tympanium, a bone of the jaw articular with the steps. It receives vibration of the substantium. In other reptiles, a tympanium is on the surface or in a small depression in the head. The inner air of reptiles is similar to that of amphibians. Air in birds. Hearing is well developed in most birds. Loose delicate feathers cover the external air opening. Middle and inner air structure are similar to those of mammals. Air in mammals. Early mammals. Auditory senses were also important to the early mammals. Adaptation है इनके. Adaptation include the air flap, the auricle, the auditory tube. It leads to the tympanium. It directs sounds to the middle air Cochlea. It in mammals, the long coiled sensory structure of the inner ear that contains receptor for sound is the cochlea. Cochlea. This structure provides more surface area for receptor cells. It cochlea gives mammals greater sensitive to pitch and volume. ये एयर इन मैमल्स की स्ट्रक्चर द आउटर एयर में मिडल एयर एंड इनर एयर बताई गई है. इसमें पिन्ना है, ऑडिटरी कैनाल है, ओसिलस है, सेमिरिकुलर कैनाल्स है, वेस्टिब्यूलर नर्व है, टिम्पैनिक मेम्ब्रेन है. स्ट्रक्चर ऑफ ह्यूमन एयर. द ह्यूमन एयर हैज़ 3 डिवीजन: outer air, middle air, inner air. Outer air. The outer air consists of the urethral and external auditory canal. Middle air. The middle air begins at the tympanic membrane, eardrum. It ends inside the skull. 2 small membranous opening the oval and around windows are located. Air oculus. The 3 small oculus are between the tympanic membrane and the oval window. These oculus are malleus, hammer, stabs. These are named according to their shapes. This figure the components of the middle ear. The narrow escutcheon tube leads downward from the air-filled middle ear chamber into the rear of the mouth. Auditory tube. The auditory tube extends from the middle ear to the nasopharynx. It equalizes air pressure between the middle ear and throat. Inner ear. The inner air 3 components: vestibule, semicrural canals. Vestibule concerned with equilibrium. Semicrural canals, these are concerned with equilibrium. These are 3 semicrural canals. Hearing mechanism or process. The process of hearing can be summarized as follows: sound waves enter in the outer air. It creates pressure waves. These waves reach the tympanic membrane. A magnified view of the organ of corti. Inner hair cell, tectorial membrane, outer hair cell, supporting cells, tunnel of corti, nerve fiber, basilar membrane, cochlea nerve. Available frequency of sound waves. Humans are not able to hear low pitched sound below 20 cycles per second, although some other vertebrates can do. Young children can hear high pitched sound up to 20,000 cycles per sound. This ability decreases with the age. Other vertebrates like dogs can easily detect sound 40,000 cycles per sound. When the body is still, the otoliths in the semicircular canals rest on the hair cells. When the head body moves horizontally or vertically, the granules are displaced. It causes as the gelatinous material to sag. This displacement bends to hair slightly. As a result, hair cells initiate to generate potential, and then the ocean potential. Continuous movement of the fluid in the semicranial canals cause motion sickness in humans. Sense of equilibrium. In mammal, the sense of equilibrium is divided into separate sense: static equilibrium, dynamic equilibrium. Static equilibrium refers to sensing movement in one plane. Dynamic equilibrium refers to sensing angular and or rotational movement.